What are the odds that two lines chosen at random in a plane will intersect? It's nearly 100%. That means that if they don't intersect, if they're parallel, they're special. And you might, let's see, take one line here with a slope of 2, rise of 2 over 1, 2 over 1. If the two lines are parallel, they'll have the same slope. You might write it like this with parallel to remember that they have the same slope. So let's start with some parallel lines, and we'll draw a transversal crossing it at an angle of 30 degrees. Can you find any other angles that are 30 degrees? There's a vertical pair, there's corresponding angles, another vertical pair of alternate interior angles. Oh, but that angle's not 30 degrees. Wait a minute, that's a linear pair. So the two angles have to add to 180, which means that this dot is 150 degrees. All of the dots are the same, but now the triangle angle sum theorem, which is what we're going to prove here, it says that the three angles of a triangle sum to 180. Now, if you look, we draw an auxiliary line, the alternate interior angles are congruent. These three angles form a straight angle. So if you add them all together, they'll equal to 180 degrees, which means that the three angles of the triangle have to sum to 180. And that's what the triangle angle sum theorem says. Angle in a triangle, well, the measures of the angle sum to 180. So here's a triangle, and if we have ABC sum to are 180, well, C and D also are 180. These two must be the same then. That is, an exterior angle is equal to the sum of its remote interior angles. So if this is the exterior angle, it's equal to the sum of its remote interior angles. These other two angles I've marked are the remote interior angles. That is not the angle right next to the exterior angle. So, see how quick that is? X is equal to the sum of its remote interior angles. Now, you could have done it the long way, where you add up all three angles and it equals to 180 and subtract it from 180 and do all that business, but it's a lot quicker to do it using the exterior angle theorem. For instance, here's a problem. You could start off by saying all three angles of a triangle sum to 180. That's certainly one way of doing it, but instead, if you look at the exterior angle as the sum of its remote interior angles, that's x plus y. You solve for y and plug it in, then all you have to do is just plug in for x and you've got it, 40 degrees. I'm going to show you a problem-solving strategy. If you identify the relationship, you devise a plan that is you write an equation, execute the plan, and then answer the question that is asked. This will get you through just about any problem. And here we have a problem. We're going to talk about auxiliary lines. You could extend the lines. If you do that, it might be easier to identify the relationship. Like right here, we have a straight angle. So if you add up all three of these angles, you're going to get 180 degrees, and you can easily solve for x. So divide both sides by 6, x is equal to 30 degrees. Now, more on auxiliary lines. Let's look at a problem. We're going to do it three different ways, drawing the auxiliary lines in three different ways. We'll start off with this situation. You have parallel lines. I didn't draw them on here. I should have drawn parallel lines. There we go, marked them parallel. Now, what is the relationship here? Well, these alternate interior angles, the one is 6x and the other is 50. Now, the relationship, this is part of this idea, identify the relationship. Well, x plus 50 is 90, so x is 40. We could have drawn the auxiliary line, instead of drawing it straight across and parallel to the others, I could have just extended one of the lines. You extend one of the lines, and now you've got the three angles of this triangle sum to 180. So x plus 50 plus 90 is 180, or x is 40. That's a second way of drawing the auxiliary line. Let's look at a third way of drawing the auxiliary line. What if instead we drew a perpendicular to these parallel lines? Now if you do that, this one angle is 40, this one is 50, and then the x is going to be 40 when you solve for it. So three different ways of solving using auxiliary lines. How would you draw auxiliary lines here? Let's say if we extend the lines. Sometimes it helps, sometimes it doesn't help. Here you have alternate interior angles, so the relationship is that those two angles sum to 180. If we divide both sides by 8, we get x is 22 and a half. Let's look at another problem similar to the last one. This is like a test question. This one keeps coming up. Okay, well, those two angles, alternate interior angles, x is just the sum of those two angles. Auxiliary lines really are helpful, aren't they? Now, this is a problem. How would we solve this? Let's just start with what we know. Now set up an equation based on what we know. Well, we know the two angles form a straight angle. And there you have a triangle, so you could add those up to 180. And then you could solve this. And there's a lot of different ways of solving problems.